Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the IAM System, the identity and access management engine that decides who can do what across cloud services, applications, and data resources. We'll cover how platforms like AWS IAM, Google Cloud IAM, Azure Active Directory, and Okta manage users, groups, roles, policies, authentication, authorization, and audit trails at scale. Whether you're preparing for a senior engineering interview or building identity infrastructure at scale, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the IAM System, the identity and access management engine that decides who can do what across cloud services, applications, and data resources. If you have ever wondered how platforms like AWS IAM, Google Cloud IAM, Azure Active Directory, or Okta manage users, groups, roles, permissions, policies, authentication, authorization, and audit trails at scale, this video is for you. We'll walk through the functional requirements, non-functional requirements, system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FAANG interview or building identity infrastructure, let's get into it. Here is the core problem. A modern organization runs hundreds of microservices, thousands of employees, countless APIs, databases, storage buckets, and compute resources. Everyone needs access, but giving the right access to the right entity at the right time is incredibly hard. Manual access requests lead to slow onboarding. Overprivileging creates security risk. Role explosion makes management impossible. Stale permissions let former employees or abandoned service accounts retain access. Ad hoc authorization logic is scattered across services so no one knows who can access what. When an auditor or a security incident asks who accessed this sensitive data, and when, the answer is buried in incompatible logs or missing entirely. The business needs a centralized IAM system that authenticates identities, evaluates policies, enforces least privilege, and produces a complete audit trail. Let's walk through the functional requirements. First, identity management. The system must store and manage users, groups, service accounts, and external identities, with lifecycle operations like create, update, disable, delete, and federation. Second, authentication. It must support password-based login, multi-factor authentication, single sign-on, OAuth, OpenID Connect, and SAML federation. Third, authorization. It must support role-based access control, attribute-based access control, resource policies, and fine-grained permission evaluation. Fourth, policy management. Administrators must be able to write, version, test, and attach policies to identities and resources. Fifth, audit and compliance. Every authentication attempt, authorization decision, administrative change, and privileged action must be logged immutably with timestamps and context. Sixth, session management. The system must issue, validate, refresh, and revoke tokens and sessions. These 6 capabilities make IAM secure and usable at scale. Now the non-functional requirements. The authorization path must be extremely low latency because every API call may require a permission check, often targeting single-digit millisecond P95. The system must be highly available. If IAM is down, the entire platform may become unreachable, so it needs redundancy and graceful degradation. The system must be secure by design. Credentials must be hashed, tokens must be signed and short-lived, and secrets must be rotated. It must scale horizontally to support millions of identities and billions of daily authorization requests. Consistency matters for policy updates. A newly denied permission should take effect quickly without breaking cache decisions. Audit logs must be tamper-evident and retained for compliance. The system must be extensible to support new identity providers, resource types, and policy languages. Here is the high-level system architecture. On the left, identities arrive through multiple channels: human users via web and mobile login, service accounts via API keys, and federated users via SAML or OIDC identity providers. The authentication service verifies credentials, runs multi-factor checks, and issues signed access tokens and refresh tokens. The policy administration point lets administrators define roles, policies, and attribute mappings. The policy decision point evaluates authorization requests against policies and returns allow or deny decisions. The policy enforcement point sits inside each application or gateway and intercepts requests. The identity directory stores users, groups, credentials, and metadata. The audit service collects logs from every component into a tamper evidence store. An admin console and developer APIs provide management and automation interfaces. The key components to memorize cold. Identity provider handles authentication and token issuance. Directory service stores users, groups, credentials, and organizational hierarchy. Policy engine evaluates RBAC, ABAC, and resource-based policies in milliseconds. Authorization service caches decisions and provides standard APIs like check access and list permissions. Session and token store manages active sessions, refresh tokens, and revocation lists. Audit logger captures every authentication, authorization, and administrative event. Admin console provides role management, policy editing, and access reviews. Resource service mapper keeps track of which resources exist and what actions they support. Together, these components form the backbone of enterprise IAM. Let's trace the end-to-end user journey. A cloud administrator is onboarding a new data analyst. She opens the IAM admin console, creates a user identity, and adds the user to the data analysts group. The group already has a role attached that grants read-only access to analytics databases and query APIs. The user logs in through the company's single sign-on portal, completes multi-factor authentication, and receives an access token. She then tries to run a query against a customer data warehouse. The application calls the policy decision point, which checks the user's role, department attribute, time of day, and the resource's sensitivity label. The policy allows read access but denies any export or delete action. The user gets the data she needs, and every step is recorded in the audit log for compliance. The core models and algorithms. A user represents a human or service identity. A group collects users for easier administration. A role is a collection of permissions that can be assumed. A policy is a declarative rule that maps identities, actions, resources, and conditions to an effect. A permission is a granular action on a resource type, such as S3, getObject or DB, select. A resource is a protected entity with an owner, tags, and supported actions. A session records the authenticated context including tokens, expiry, and device information. An audit event captures actor, action, resource, decision, timestamp, and request context. The policy evaluation algorithm resolves role assignments, expands groups, evaluates attribute conditions, and returns a deterministic decision. The key trade-off is expressiveness versus performance. ABAC is flexible but slower to evaluate, while RBAC is fast but coarse. Now the low-level design deep dive. Authentication begins with credential validation against a directory service, followed by multi-factor verification and token issuance. Access tokens are short-lived JSON web tokens signed with asymmetric keys, while refresh tokens are long-lived opaque identifiers stored in a secure session store. The authorization pipeline is implemented as a request interceptor, a policy decision point, and a local evaluation cache. The policy decision point loads applicable policies, expands group and role memberships, evaluates attribute conditions, and returns allow or deny. For high throughput, decisions are cached with a short TTL and invalidated when policies or memberships change. The data model uses relational tables for users, groups, roles, and policies, plus a graph or index for membership traversal. Audit events are written to an append-only log and asynchronously replicated to a long-term store. Key takeaways for your interview. First, IAM is not just login. It is identity, authentication, authorization, and audit together, so design all 4 layers. Second, separate authentication from authorization. Issue tokens at login, then evaluate policies per request without re-authenticating. Third, choose RBAC for simplicity and ABAC for fine-grained context-aware control, and be ready to discuss hybrid approaches. Fourth, policy evaluation must be fast and cacheable because it sits on the critical path of every API call. Fifth, audit everything immutably. Compliance, incident response, and access reviews all depend on trustworthy logs. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the IAM system. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the IAM system. We covered the full picture, from identity providers and authentication, through RBAC, ABAC, policy engines, authorization pipelines, and the low-level design of tokens, sessions, and audit logs. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.